Now, here we are going to start with the uses of nitric acid. So, nitric acid is actually you can say that is being used in different fields. So, let us focus that where and why it is helping in many fields. So, the first is that it is used to purify gold and silver. As I told you that there are that thing you can say that it has a property that it can even dissolve the noble metals. So, that means it is somehow useful in removing the impurities, and in doing that it purifies gold and silver. Second is that it acts as a rocket fuel which is used in a spacecrafts and all. So, it acts as a rocket fuel, that means it is used that and on burning it produces the required energy. Third is that it is used in preparation of many fertilizers. What are fertilizers? As you all know, fertilizers are the substances which are used in order to increase the fertility of the soil, like calcium nitrate, ammonium nitrate. These are all good fertilizers which are actually used to enhance the fertility of the soil. Next, it is used in manufacturing of explosive, batteries, etc. So, it is being used there also. Third, as I told you, aqua regia is serving an important use, and the main constituent of aqua regia is HCl and HNO3. So, there also it acts as a constituent. Next is that it is a powerful oxidizing agent. This is one of the important property actually. It acts as a powerful oxidizing agent, and it has the ability to you can say oxidize this thing, even metals, non-metals, organic as well as inorganic substances. So, actually the reason behind that is that when it undergoes decomposition, it evolves the nascent oxygen. The nascent oxygen that it evolves helps in oxidizing the substance. So, let us see that how it oxidizes actually. So, here I have few examples of non-metals. So, see that non-metal whenever react with the nitric acid, they are always going to produce respective gases, or you can say respective oxides, and somehow we can also get the oxyacids. Like if when we dissolve C in HNO3, what do we get? C get oxidized to CO2, N gets oxidized to N2O, and H get oxidized to H2O. That means it is oxidizing all the elements H, N and C, all are getting oxidized. Second example I have is sulfur, and see when I dissolve sulfur in HNO3, I get respective gases as well as we get the oxyacids. So, the oxyacid of sulfur is something H2SO4, right. So, we get H2SO4, N gets oxidized to NO2, H gets oxidized to H2O. So, that means it has the power actually to oxidize the elements and also to form the oxyacids when we are talking of the non-metals. But in case of metals actually like what product we are going to get actually depends upon the concentration of the acid and also on the temperature condition. That means two factors, that is the concentration of the acid and the temperature factor is going to matter, that the given HNO3 is getting oxidized to which or what substance will be forming in different situation. So, see if I have a metal, let us say if we have a zinc metal and we are dissolving in HNO3 and the concentration of HNO3 is 6%, that means it is very dilute. So, what do we get? Obviously, we will be getting a metal nitrate. Right, so we will get a metal nitrate, and this HNO3 actually gets oxidized to form NH4NO3, and along with that we get water also. So, you need to remember that when we are talking about very dilute acid, then HNO3 gets reduced, this thing transforms into ammonium nitrate. And when we react Zn with HNO3, 20% actually the concentration HNO3, that is it is a dilute as well as cold, then again we get zinc nitrate. We will be getting zinc nitrate in all the cases, right. So, we are getting zinc nitrate in this case, and this is getting changed into N2O, right. So, you need to remember that actually. And when we dissolve zinc in HNO3 which is 50% concentration, that means it is cold and concentrated somehow. So, when it gets, again we are going to get zinc zinc nitrate, and along with that we will get NO. And when we are reacting with highly concentrated acid, so we will see that everything just gets oxidized, zinc forms zinc nitrate, H forms H2O and N forms NO2. So, you need to remember actually that what percentage or what concentration of acid is being used and what is the temperature actually, whether it is dilute or cold. So, you need to learn all those, right. So, when you are, I think it is clear that when you are reacting with very dilute, you get NH4NO3. When you are reacting with dilute and cold, 20%, right, we get N2O, and when we are reacting with cold and concentrated we get NO, and when we are reacting with cold and highly concentrated, what do we get? We get H2O and NO2. So that means it is actually you can say that serving an important use of this thing oxidation, or that means it is acting as a powerful oxidizing agent. That means it is oxidizing the other substance and then getting reduced itself. As you saw that in this HNO3 gets reduced to NH4NO3, this in this case it gets reduced to N2O, here it gets reduced to NO, and here it gets to reduced to actually NO2. The reason behind this is actually can be this also, that actually the main element in it is nitrogen, and we know that nitrogen forms variety of oxides. So likewise at different concentration we are getting different nitrogen oxides or compounds. The last use is that it is used in forming the drugs, dyes and perfumes also. So I think it's clear that nitric acid is actually a you can say important lab reagent, because it is being used in various fields and helping in various ways. So just try to learn them, the uses, list them up, learn them up, and also try to find out the reason also, because these questions can come in reasoning also, right? That how it can use to be purify gold and silver, what is aqua regia, or what are the conditions that actually affect the oxidizing power of the HNO3. So you need to learn all those things, right? So this is the uses, and these were the chemical properties, and physical properties we already did. So just go through it.